There's something hidden in this scene. Can you spot it? There it is, blending right into the environment. This is the trick behind Meccha Chameleon. 15 million copies in 3 weeks, made by 2 devs. You sample colors from the environment to try to hide in plain sight. So, I gave myself a challenge. Build it in Unity 6. The movement, the camera, the pose switching, all of that seemed easy enough. But the painting and color sampling itself? I had no idea how to build it. First, we need to understand why it's so tricky. To create a painting mechanic in Unity, you need a texture created at runtime on which you will paint, and this texture needs to be applied to, in our case, the player model. But it only works if the model's UVs don't overlap. Otherwise, one stroke on the chest ends up in 3 places at once. You also need to convert the position where you click on the model to the UV space so that you paint on the correct section of your texture. To get that UV position from a click, you need a collider that exactly matches the current pose. So for a skinned character, you bake one at runtime. All of this sounds quite simple, at least if you only plan on using the color picker UI for painting. What if we want to sample the color from the environment? Well, this is where things get tricky. First of all, we can sample the color of what the camera sees, which looks okay in the color picker, but when we paint it, the light calculations are applied twice. Once in the screenshot, once on the character, and the color looks off. We could instead try sampling the albedo color of each object to avoid that, but if your environment uses custom shaders, it's tricky to get the albedo before lighting is applied. Also, the colors might still not match if your player character uses a different shader. To find a solution, I set up a test project. I used the stylized house interior pack for the environment, since it has lots of colors and patterns to test our painting mechanic. The design mascot seems like the perfect player model. I just had to make sure each part of the body has its own UV island. Otherwise, the painting mechanic simply wouldn't work correctly. And the flexible color picker, because there's no point building that UI from scratch. All 3 assets are currently free, so you can follow along and try this yourself. My environment pack came with a test scene which looks perfect for our playground. But there's one catch. The kitchen props use a custom shader. So do the walls. The test scene had way too many lights, so I turned them all off. But walls are still lit by ambient light, while the kitchen is very dark. If we try to sample their color, it's going to look completely off once painted onto our character. All of the props use LODs, but we only need the highest detail version for our painting mechanic. The existing mesh colliders use simplified meshes attached to parent objects, which is great for performance, but we need to use an accurate collider generated from our mesh. For our painting mechanic, reading the albedo color starts with using a raycast to hit an object. If the collider sits directly on the same object as the mesh renderer, it makes accessing the material and its texture so much simpler. I can easily remove the extra LOD objects, the LOD group component, and even add a mesh collider to each LOD0 object. But if I try to swap the shaders on those materials, I lose all the assigned textures. Reassigning all of these by hand would be a lot of work, so I brought in some help. 𝗶𝘂𝗲𝘀, the sponsor of this video. It's a dev assistant built specifically for Unity. It connects right into your editor and actually understands your project, your scripts, scenes, and assets. And spoiler, it helped me build the painting mechanic itself. But first, it helped me with the project setup. I select plan mode, and in the prompt I can use the @ symbol to reference the parent object with all the props. Since 𝗶𝘂𝗲 is project aware, it lists everything I might mean. Then I describe what I want, which is to swap the shaders of the materials to URP Lit. You can pick a model from the list and press Send. 𝗶𝘂𝗲 may ask a few clarifying questions before planning. And in a minute, I see a plan that 𝗶𝘂𝗲 has created. Always read through the plan. You can make mistakes. And ask for adjustments if something's off. When you're satisfied, just press Build Plan. And after a few minutes, 𝗶𝘂𝗲 has swapped the shaders. Now all the props are lit the same way by the ambient light. Simple tasks like that can eat a lot of your time, but 𝗶𝘂𝗲 can easily do those for you. I did have to adjust a few tiling parameters manually. Then I fixed the lighting, added the character, and set up the camera. Now all the elements of the scene are using a URP Lit shader. The scene doesn't look as pretty as before, but all the shader parameters of the props are the same as those applied to the material of our player character. So the colors we sample and paint onto our character will actually match, and the player can blend right into the environment. Back in 𝗶𝘂𝗲, I opened a new thread in plan mode. I described the painting mechanic I want, referencing the player object and the flexible color picker, and asked 𝗶𝘂𝗲 to split the work into steps. For creating a plan, I like to select a more advanced model. This part matters. Only you know what you're actually building. And when the agent finishes a testable step, playtest it and give feedback right away. Here's the plan. I read through it. All 4 steps check out. We could swap the model for a cheaper one, but the first step is the hardest part, so I'll stay on the smarter model. Okay, 𝗶𝘂𝗲 is done with phase 1. Let's test it. Apparently, I can paint by clicking and holding the left mouse button. But nothing happens. And here's the culprit. The mesh collider is tiny and has an incorrect rotation. We will have to rebake the mesh each time the player changes pose, so let's combine the feedback with this new requirement. I switched to agent mode before sending the feedback. The fix is to call skinnedmeshRender.bakeMesh to get the runtime baked geometry. One caveat: bakemesh only respects a custom scale if its use scale parameter is true. And my player model uses a custom scale, which would explain the size problem. So let me open the generated script, find the rebake collider method, and flip it myself. Let's try again. This time the mesh collider looks good. And I am pretty impressed. We can actually paint on our player model. And this is the point. 𝗶𝘂𝗲𝗀 did the heavy lifting, but spotting the scale flag was on me. The agent builds, but you're still the one who designs the project and tests that it actually works. So let's approve phase 1 and move on to phase 2. Since the hardest part is behind us, I'll switch to a cheaper model for phase 2 and 3. A few minutes later, the color picker is in. I pick a color and it paints straight onto the player. One quirk: the picker's gradient square doesn't update its hue. I don't think it's worth fixing right now. Let's move on to phase 3. Brush size control on the right mouse drag. 𝗶𝘂𝗲𝗀 added new brush size serialized fields to our script. In play mode, I can now hold the right mouse button and drag to modify the size of the brush, but while testing I realize there is no visual indicator of the current size. So that's my feedback. Add a ring indicator that shows the brush size while I drag. Notice how specific I am. The exact look, how it should be drawn, when it should hide. The more precisely you describe what you want, the closer the first result gets. 𝗶𝘂𝗲𝗀 couldn't process my prompt in this thread, so I started a new one, pinned the plan, and sent the same prompt again. This time it went through, but in play mode, the indicator was tiny. So I took a screenshot, attached it to the prompt, and asked for a fix. After a few iterations, the ring finally matched the actual brush size and stays in place while resizing. The last phase, the eyedropper. Hold space, click anywhere in the environment and pick that color. For now, straight from what the camera sees, since it's simpler to implement. And it works! I can grab any color around me and paint it on. We even got a custom cursor icon for the eyedropper. But there's one problem. The painted color doesn't quite match the wall. And the sampling itself is fine. In Affinity Photo, the picked color matches the wall exactly. It only goes wrong when we paint it on our character. The color already has the lighting baked in, and then the character gets lit again on top. The plan is complete. The painting mechanic isn't. The character can't blend in if the colors are off. Before planning anything, I opened a new thread, switched to Ask mode with a simple question. Can we read the albedo color, the color before lighting, if all the models use URP Lit shader? 𝗶𝘃𝗲𝗁𝗀 answer? Yes. And here's where unifying the shaders pays off. With everything on URP Lit, the albedo is simply the base texture multiplied by the material's tint color. It laid out a few ways to read it, and even warned me that the camera's opaque texture is exactly the wrong source because it's already lit. So, a new plan. Switch the eyedropper to albedo sampling with a bool flag to flip between the two solutions, keeping the camera logic as a backup. It's a smaller feature, so no faces. I asked 𝗶𝘃𝗲𝗀 to implement the whole plan in one go. And there's our switch. Albedo or camera sampling, one checkbox. Let's test this. I sample the wall, paint it over the player, and the color finally matches. No more mismatch. Picking different spots even gives different colors. We're reading the actual texture now, not just a tint. Shadows still betray the player's shape, but that's to be expected. The most difficult part is done. Our painting mechanic is finally working. I have set up a follow camera and asked 𝗶𝘃𝗲𝗀 to prepare a simple movement system based on the camera direction. We can also slide up and down when we are close to a surface. I have prepared a few different poses in Blender, and 𝗶𝘃𝗲𝗀 helped me prototype a pose switching UI. Now we can walk around, press R to switch pose, and enter paint mode to start painting. And because the collider rebakes for every pose, painting works no matter how we're standing. Here is the result. I can move to a good spot, pick a pose, and paint using the color of the props around me. That is exact scene you saw at the beginning of this video. You just didn't know where to look. This was a fun project, but the best part? The painting mechanic I had no idea how to build? We build. That's what 𝗶𝘃𝗲𝗀 is for. Download 𝗶𝘃𝗲𝗀 today and get 100 free credits. Link is in the description and pinned comment. Thanks for watching.